Ladies and gentlemen, I am Shin-Ku Lee from National Cheng Kung University, Taiwan. It's my pleasure to give a talk to share some of my research experience and outputs about the low-carbon green building development. As well known, the Paris Agreement sets the overall objective to limit the average global temperature increase to well below 1.5 degrees Celsius. The IPCC special report states that in order not to exceed the 1.5 degree of global temperature increase, global net CO2 emissions should fall until 2030 by about 45% from 2010 levels and reaching carbon neutral by 2050. Buildings are major energy consumers, currently accounts for about 30 to 40% of total energy consumption in a country. In buildings, energy is consumed for the provision of energy service such as heating, cooling, lighting, appliance, water heating. Despite the expected increase in demand for cooling due to rising average global temperatures, the building sector still shows high potential for reduced carbon emissions. Therefore, World Green Building Council set two goals in the roadmap for carbon neutral 2050 in building. That is, in all new buildings must operate at net zero carbon in 2030. All buildings must operate at net zero carbon at 2050. Main decarbonization drivers in the building sector include energy efficiency, that is, improve the energy performance of all equipment in building, and the building insulation, and the application of the renewable energy. In the next few minutes, I will introduce a cargo container building in a case study to show how to find the total solutions for reducing the energy consumption of this building. This project was started from an existing cargo container building. The location of this building is in the southern area of Taiwan. This facing south building is a two-story office building. It was composed of 20 cargo containers with 20 feet in length. There are 32 occupants in the main office area. Two split type air conditioners were installed in each floor. Firstly, we investigate the indoor environment conditions in this existing building. In the IAQ issue, we found that the concentration of CO2 and ozone exists the limitation value of building core due to poor ventilation. And there are several natural openings were designed in this building, but all of these openings are closed for preventing the leakage of cooling air in order to save the energy consumption of this building so that it creates the IAQ problem in this building. Next, we investigate the visual environment problems, and we find that a high luminance contrast between the external white wall and the computer screen caused glare, so that a translucent plate was used as a light diffuser to reduce the excessive brightness contrast. In the thermal environment issues, the indoor air temperature distribution is not uniform. We could find that the temperature in the area B and the area VR is lower than that of the temperature in the rest of other area. This phenomena led to the thermal discomfortable problem here. Therefore, we proposed an integrated solution and to improve the energy efficiency and to improve all the indoor environment quality problem in this building. And we propose to add the radiation barrier blanket and rooftop PV system and on the roof of this exist. And we install the light redirecting glass, the energy efficient laminated glass, and the solar control fin, and on the glass element. In addition, we use one kind of the novel cement mortar and mix with the phase change material and the aerogel in the building envelope of this existing building. So let we understand and explain all the functions of this green building material used in this building. And the first of one is the cool roof painting. We could understand we paint the high reflective coating named cool roof paintings on the roof of a building. It could reflect the most of the radiation energy led to the surface temperature of the roof decrease as low as the 10 degrees Celsius, so that the surface temperature and on the cool roof painting surface is lower than and that we now paint the cool roof painting. And then next, we use the radiation barrier blanket. And this radiation barrier blanket is composed of one or several air layers in this blanket, so that the thermal conductivity of this blanket could be decreased. Therefore, without the installation of radiation barrier blanket, the roof temperature of this cargo container building is higher to about 50 degrees Celsius. And after the installation of this radiation barrier blanket, the temperature of the roof temperature of this cargo container building could decrease to 31 degrees Celsius. We could find that there is a significant effect on the reduction of the surface temperature due to the installation of radiation barrier blanket. And the third building material we used is one kind of the novel cement mortar mixed with the phase change material and aerogel. And this is the illustration of this material. And we bought a cement mortar with the PCM and the aerogel on the interior surface of the cargo container envelope. And then we add one layer of the glass fiber or wood fiber blanket. And finally, we use the one plate and on the in the interior surface of this cargo container. And we could use the IR image temperature detector to measure the temperature surface temperature distribution of this cargo container as we coat this novel cement mortar mixed with the PCM and the aerogel. The surface temperature on the interior surface of the envelope and could decrease to 32 degrees Celsius. And then we measure the overall thermal performance of this solution. We find that the thermal transmittance of the this solution is 1.51 watt per square K, and the U value of this solution is lower than that of the traditional RC construction work, and the U value of the traditional RC construction work is about 3.5 watt per square K. And then, in order to block the solar radiation penetrated through the glasses in this building, we use the solar control film adhered on the interior surface of the glass. We choose the one kind of the solar control film with the high visual light transmittance and high near IR spectrum reflectance, so that the most of the solar radiation energy could be blocked and on the surface of the glass, so that the electricity consumption of the air conditioner is significantly reduced, as the solar control film was attached on the large area glass curtain in this case study, especially in the summer of July to September in Taiwan. And the electricity consumption of the air conditioning system after renovative in this case study is reduced by 25% compared with that before renovative. In addition, we would like to solve the glare problem. We install the daylighting and the ventilation window and on the roof of some specific room. Okay, we can find that, and this daylighting and the ventilation window could improve the ventilation efficiency in a closure space. Then, and the daylighting and the ventilation window could provide enough luminance and to light the space in a room. Finally, the energy saving result in this case study show that the electricity consumption could be saved and about 66.6%, and including the PV panel, and because in Taiwan the solar radiation intensity is very high, so that the PV power could generate about 30% of the total energy consumption, so that we could find that, and we use some of the total solutions and to decrease the thermal insulation of this cargo container building, and we installed the PV power generation system and could achieve 16% energy saving in this case study if we conducted the additional renovation solutions, such as replace the high performance air conditioning system and install the energy management system. We could predict that, and this case study could achieve the net zero energy building, and in these conditions. And after the first generation of the cargo container building development, and we try to add the building energy systems, and in our second generation low carbon cargo container building. That means we add the battery storage system to store the PV, the power generated by the renewable energy system, such as the PV system. And we use the advanced energy management system to sense, to measure and control all the electricity consumption behavior, and in this the two generation low carbon cargo container buildings. And this and the project is still ongoing to measure and to verify the purpose of all these two additional solutions in this building. And then right now we have created the third generation cargo container building named net zero energy cargo container building. In this building, and we used all the previous solutions, and in this cargo container building. In addition, we added some of the advanced materials, such as we use the smart fin window in this building, and the smart fin could control the transmittance of the glass systems. So, for example, in the sunshine condition, the smart fin will be closed so that the solar transmittance could be reductions, so that the solar radiation energy could be reduced in the morning and the afternoon, and in the evening, and the smart fin could be opened to let some of the reflection or diffuse the solar energy penetrate through the glass system into the interior space in order to enhance the thermal environment of the environment. And we also developed an occupant the central and control technology, and to measure and to sense all the activity of occupant in this building, in order to find the optimal control scheme, and to achieve the minimize the energy consumption, and the maximum the occupant the comfortable condition in this building. In addition, we use some of the advanced aerogel application materials in this building. First of the aerogel application material is aerogel porous board, and the aerogel porous board and on the high specific surface area, and the porosity of the aerogel porous board is near the 90%. That means most of the materials is filled with the air. That means the thermal conductivity of the aerogel porous board is very low. The thermal conductivity of the aerogel porous board is 0.033. That means, and the use this aerogel porous board could decrease the thermal performance of the building envelope. As shown in this slide, we added this aerogel porous board in the near of a cladding. The U value could be decreased from the 3.5 to 1.4 watt per square K. And the second, the application of the aerogel material is aerogel motor. We developed an innovative aerogel motor to mix the aerogel particle into the typical motor to let the thermal conductivity and to decrease from the 1.5 to the 0.083. That means the total thermal performance of RC world could be increased, so that the U value of the innovative RC world could be decreased from the 3.5 to 1.63, and so that we try to find all the solutions to helping existing building to achieve the goal of the net zero energy. So right now, several the experiment is still ongoing, and to verify all the function of these solutions. That is all we have been done in Taiwan. So thank you for your listening.